just like each of the polygons that we looked at in the last lesson, regular polygons are going to have a formula to find their area as well. But I wanted to do a little bit of exploration first, kind of see if we can arrive at that formula. So first of all, this word regular, this has to mean something specific because otherwise we're not going to have a formula that applies to all of these things. So that word regular is very specific, and it means that it's equilateral, which we've seen that word before, usually talking about triangles, but equilateral just means that all of the sides are congruent. And then it also means that it's equiangular. Equiangular, which means that all of the angles are congruent. So that word regular is actually pretty fitting for these because it is that version of the polygon that you think about. So if you hear octagon, you're probably thinking about a stop sign-like shape instead of an 8-sided irregular polygon that's kind of a potato shape. They're both octagons, but it's going to be a lot more challenging to find the area of the potato irregular type octagon than it is to find the area of the regular octagon, because that regular octagon stop sign shape has a lot of uniformity to it. Since it is equilateral and equiangular, it's a lot easier to approach the area of. So before I show you the formula, I want you to think about the pentagon that we've got right here. If you were going to find the area of this pentagon and say you did not have a formula, but you could use the formulas of other shapes, so you could possibly break down this pentagon into other shapes, how would you go about finding the area of it? So there are several different ways that we could break up our pentagon, and hopefully you thought through one of those ways. You could break it up into a triangle and a trapezoid, 3 triangles, 5 triangles. I'm sure there are other ways as well, but our objective here is to figure out a way that we could break this up that works not only for this pentagon, but for every regular polygon. So something that can work for any regular polygon is if we take the center of that polygon and then we draw from the center to the vertex for each of these links. And what's going to happen every single time is that we're going to have the same amount of triangles as we have sides. So since this was a pentagon, we end up with 5 triangles. And this is a little off because I'm the one that created it and cut it, so a little bit of human error. But all of these triangles should be congruent. They should be exactly the same. So if I can figure out the area of one of these triangles, then I could just multiply it by 5 to have the area of the entire pentagon. So we're going to look at one of these triangles. So from our last lesson, I know that the area of just this one triangle is 1/2 base times height. So what exactly is its base and height going to be? I know that the bottom of this, that could be counted as the base, and remember that this was the side of the original polygon, so I'm going to go ahead and call this S for side. Okay, but then for the height of this, I would need to know this length right here. This would be the height of the triangle. Notice where it is in relation to the polygon. It wasn't that length from the center to the vertex, it was from the center to the center of this side. So before we go any further here, I think we're going to need some vocab so that we're not just like pointing to random things in the polygon. So these links that we just drew from the center to the vertices, each one of those is called a radius. So that would be the radius length of the polygon. Just like a circle, that center to the circle is the radius. For this, the center to the vertex is a radius. But this length right here, the center to the center of the side, is called an apothem. So this length right here is called an apothem. And yes, it does sound like possum with a lisp. So using our new words, if we're finding the area of this one triangle, we said that was going to be 1/2 the base, which is the side length, times the height, which we now said is called the apothem. So I'm going to use the letter A for that. So if that's one triangle, 1/2 side length times the apothem, that means that my whole pentagon, since it has 5 of these triangles in it, is just going to be 5 times 1/2 side length times the apothem. Okay, so we're about there with our formula for this. What I want you to notice, and sorry about having an S and a 5 in there, my bad. What I want you to notice is that this 5 in the side length, if I multiply, say my side length is 10, and I multiply 5 times 10, what did I actually just find? Yeah, that's right. I found the perimeter, because since it's regular, I would just be adding that same side 5 times. So if that side length is 10, it would be 10 plus 10 plus 10 plus 10 plus 10, which is really just 5 times 10. So this 5 times the side length is actually just the perimeter, which makes our formula 1/2 the perimeter times the apothem, or actually more likely, we switch them around and say 1/2 the apothem times the perimeter. And that is our formula. So let's look at a few examples. If you haven't been taking notes so far, right now is a good time to start. Go ahead and draw yourself example 1 as best you can, and then let's jump into this. So sometimes all of the information that we need will already be right there in the problem given to us. So notice for this one that we are given that length from the center to the midpoint of the side, which is the apothem. So make sure you're picking the right piece here, because remember that 18 inches is the radius, the 13 is our apothem. So we're going to go ahead and say that that's our apothem, it's 13. To find the perimeter of this shape, I've got a side length of 14, and remember that it is regular, so that means that this is 14, and this is 14, 14, 14, 14. So I could just add 14 for 6 times, because there are 6 sides, but I can also just take the side length times my number of sides, so 14 times 6, which is 84. Okay, so that's our perimeter. So then using our formula, we've got 1/2 the apothem, which was 13, times the perimeter of 84. And just multiplying those 3 values together, we'll get 546. This is area, so make sure we're still saying those units squared, so inches squared. For example 2, we're back to a pentagon. And notice on this one that they give us the side length, and it still happens to be 14. I'm not sure why those are both the same. They give us the radius is 12, but then they don't give us the apothem, and we need that in order to use our formula. So our first thing that we're going to do is go ahead and draw in an apothem, and it helps to draw in your apothem wherever you have a radius, or if you need to, go ahead and draw in a radius as well. But we want to create this right triangle, because now, what do we know about this right triangle where we can solve for the apothem? Hopefully we remember from last chapter that we are allowed to use Pythagorean theorem to solve for a side in a right triangle. What you have to be careful of here is that this length right here only went to the midpoint of the side. So that means that this leg down at the bottom is only 7 and not 14. So make sure you cut it in half, that side length. But now we can go ahead and use Pythagorean theorem. So our 7 squared plus a squared equals 12 squared to solve for a. So go ahead and use Pythagorean theorem, see what you get. So use Pythagorean theorem, take the square root of 95. We should get about 9.747. And no matter what we're going to round to at the end, it's always a safe bet to go ahead and go 3 decimal places, just so that we're being as accurate as possible. So now we have our apothem, so that 9.747. For our perimeter, we've got our side length of 14. We've got 5 sides, so we're multiplying 14 times 5. 70. And then our last step is to use our formula. And you don't have to do this every time where you're separating all of it, but I do think it helps, especially if you have to solve for the apothem. So we've got our 1/2 apothem times perimeter, and then using a calculator, we get about 341, I'm off the page, 341.145. Or if we look at our directions, oh look, some appeared at the top, round to the nearest tenth. So our 341.145 is going to be a 341.1 when we round, and it was feet squared. So our last example gives a description instead of a picture, which can be a little bit more challenging, but as long as we know our vocabulary here, we know how many sides the octagon has, it's really not too bad. So I'm going to give you a little prompting for each part, but I want you to see how much of this you now can do on your own. Because they tell us it's a regular octagon, that's what tells us we know that we're dealing with the same formula, that 1/2 apothem times perimeter. So we're going to start with the perimeter this time. See if you can tell from the description how to find the perimeter. Pause the video, see if you can do it on your own. So since our perimeter of a regular polygon is always the number of sides times the side length, so times 10, that means that our perimeter here should be 80 feet. So hopefully that's what you got for the perimeter. Next, we're going to try to find the apothem, and we were not given the apothem. So for this, we're going to need some sort of drawing, but I don't necessarily have to draw out the entire octagon. You can if you want to. Really, the only part that I need, like this last example, is that triangle, that right triangle that has legs of the apothem and half of the side, and then the hypotenuse is the radius. So we're going to go ahead and recreate that triangle. See if you can go ahead and fill in, we don't know the apothem, see if you can go ahead and fill in what we know for this other leg and what we know for the hypotenuse. So the other leg should be half of the side length, so it's going to be 5. And then our hypotenuse is the radius, so it's going to be the 13.1. All right, so once you've got it set up, go ahead and solve for the apothem. Using Pythagorean theorem, we should end up with an apothem that is about 12.108. Okay, so now it's just a matter of using our formula that we've got 1/2 our apothem 12.108 times our perimeter of 80. So it should get about 484. We're going to go and round to the nearest tenth again, 0.3 feet squared.